Hello students, this is a presentation on thermal comfort and it's targeted for 4th year architecture students. I am Dr. J.R. Mehta from Mechanical Engineering Department at MS University of Baroda. Let's first define thermal comfort. What we normally see is under the same temperature conditions and humidity conditions, different people have different feeling about the thermal comfort. While one person feels it to be too cold, the other one is okay with that, and the third one feels a bit hot. Thus, thermal comfort is related with one's mind. Can be defined as that condition of mind that expresses satisfaction with the thermal environment. This definition emphasizes that judgment of comfort is a cognitive process, and the inputs given by the people are influenced by physiological, psychological and other processes. Here a schematic of the heat exchange between human body and its ambient is given. The human body is represented by the inner circle, while the sweat is shown on its surface and clothing is also shown, and the different type of heat exchange occurring between human body and various surfaces or the surroundings are shown. It can be seen here that there is a radiative heat transfer between the surrounding surfaces and the human body. The other type of heat transfer is convective, which is the heat loss from human body into the air surrounding the body, and one more type of loss is the evaporative heat loss, which is due to the sweat being evaporated into the surrounding air. Now, there are certain parameters which affect thermal comfort. The environmental variables are air temperature, mean radiant temperature, air velocity, ambient water vapor pressure or humidity, and there are some personal variables which are related with activity and clothing. Some parameters affecting the thermal comfort and the clothing in particular is shown here. Now the activities affect the thermal comfort because at different activity levels human beings need to reject different rates of heat. For example, say for resting it's around 40 to 70 watts. So that 40 watts, or rather when one is seated quietly, that is equivalent to one metabolism rate, which is 58.1 watt per meter square. Clothing creates a resistance to the heat transfer, and one clo value is taken equivalent to 0.155 meter square Kelvin per watt. The other variables that affect thermal comfort are age, sex, length of exposure and type of activity. This slide shows the clo values of different type of clothing. So the heavier clothing like long sleeved flannel shirt offers higher thermal resistance, while there are a few which offer lower thermal resistance. The conditions for thermal comfort are measured on a scale from +3 to -3 as per the ASHRAE thermal comfort scale. It's seen that men are less sensitive to temperature and women are less sensitive to humidity. A predicted mean vote is a statistical parameter which gives a mean response of large group of people according to ASHRAE thermal sensation scale. And ASHRAE standard 55 specifies thermal comfort zone where 80% or more sedentary or slightly active persons find the environment thermally acceptable. So the predicted mean vote should be in the range of -0.5 to 5. Here the thermal comfort zone on psychrometric chart is shown. When one wears a heavy clothing at a lower temperature, also one feels comfortable, while with lighter clothing one feels comfortable even at higher temperatures. And the maximum limit of humidity ratio is acceptable is generally 12 grams of water vapor per kg of dry air. There is some overlap between the two zones of thermal comfort. So this is all about thermal comfort to start with. Thank you.